Okay, we've seen how intricate this expansion got when we ratcheted up that inner control exponent to omega naught plus 1. We used that to control some arithmetic on omega naught inside the outer control slot of the phi naught. And that was just with a 2 in the input. So we're on the inside here, we're very much analogous to where we were a while ago when we were just dealing with f, or what we call phi naught now, and we had the omega plus 1 as the control slot. So we had one little bit of successor, but then on top of the first diagonalization step. So we're somewhat analogous to that at this point. So that was with a 2 input. Let's just expand a bit on the 3. So we're still at the same exact control input, and then we're just going to do input 3, and it should be noticeably bigger, and it's going to be interesting to see what's similar and what's different. So the plus 1 on the control, that inner control, just means repeat the phi 1 of omega naught machine omega naught times. Now that's that iteration exponent that's looking for a number, and of course this number is going to provide that because we're diagonalizing in the outer phi naught. So that 3 gets fed into the omega naught, and that just means repeat this 3 times. So okay, that's not too hard to write out. Now what's going to happen with this guy? Well, this is a function. It's got this function as an input. That's a big omega 1 gadget. But the most important thing is that its first slot, the control slot, is an omega naught. So this is a function that it wants to eat a number, and it's going to put it into here. So it takes a while to get used to this, that when you've got sort of these big nested things, you look for, well, what's this, that first slot of the phi 1. This guy is in a second slot position. We're not going to worry about the internal workings of this guy. We just know, oh, that's in a second slot of a phi. That's not the kind of thing that can accept an input. This is going to accept the 3 coming from here. To be really explicit about it, we say this is the kind of function that accepts a number. By diagonalization in the outer phi naught, the 3 comes in here, and then by the rules of how phi 1 with a function on the first input works, that 3 gets fed into here. Okay, now what the heck does that do? Well, this is just a number. It's certainly a successor. It's the successor of 2. And so we're going to take the phi 1 of 3 something is by definition repeat the phi 1 of 2 dot function this many times on its input. And so that's the classic recursive iteration step. Okay, so it's kind of cool how these things blow up on the page, but I do want to actually abbreviate it so that it's not ridiculously big. Phi 1 of 2 dot, this is just the phi 1 version of what I was calling E toward the start of the videos. It's just that exponential thing, x times 2 to the x. And then phi 1 with a 3 dot is the phi 1 level version of tetration, or the tetration level of the fast-growing hierarchy. And then here's a new one. It's phi 1 with this variable input, omega naught, and I'll just call that W because it kind of looks like an omega. And then we're going to have this particular omega 1 gadget that's going to come up a lot, phi 1 of omega naught comma omega naught. You can see that showing up twice already up here. And just to have an abbreviation for that, I'll call that bold W naught. And one of the most important things is that we're often going to be putting a number into that, because I'm looking at this where this 3 is going to keep repeatedly feeding into what's happening in the left slot. We're going to be very interested in W naught of 3. Well, that's what happens when you put a 3 into this slot. Oh, that's exactly T of omega naught. And then if we have to unpack that more, we can realize that's just a abbreviation for phi 1 of 3 omega naught. Okay, so with those abbreviations, what are we getting? Okay, so we'll go back. This is what we're trying to calculate. And we can abbreviate this stuff. Oh, one thing I could have written this if you wanted to see it. There's one more step. This is when I did the phi1 of 2 repeated. I'm taking this as the iteration exponent. And so it's really coming out, the first step, it's coming out this way. The reason I had a 3 here is I did one more step combined with that, which is, okay, this is now an iterated, it's something that's an iterated with a function in the iteration slot. We know that the thing that has to happen next is this needs to eat the 3 that's going to be fed in from here. And when you feed a 3 into this guy, you look for the first slot of the outer level and you feed the 3 into there, that just becomes a 3. So that's why that was a 3 before. Okay, and we're calling that T, and then that E is eating this thing that we're abbreviating as W naught. Oops. And then over here, it's a W of W naught, because this omega naught has not been fed anything, and it won't be for a long, 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 long time. And so that's important that all of the omega naughts here are unevaluated for quite a while we're kind of doing all kinds of really fancy arithmetic with those ingredients. Okay, so that's kind of just using all those abbreviations. And then let's see, we've got to start unpacking it some more. That T is just repeated E's. So T of something, and I'm going to make this a bit bigger. I'm going to crank it up to 200%, I think. Okay. So that T of something is E to that power of that thing. So that's the standard recursive iteration. Okay. And then I need to unpack that W naught. Well, how do I unpack that? Well, this 3 is going to get handed off once again to this whole thing. So that's going to get handed off to this iteration exponent, and that's going to get handed off to this iteration exponent, and that's one of the places where the W naught of 3 collapses to a T of omega naught. So that's why this becomes T of omega naught. Okay, well, what the heck does that mean? T of something is E repeated. So that becomes another iteration exponent, E to the omega naught of omega naught. Well, finally, we've got something where we're just going to get a 3 as the iteration exponent. Because once again, the 3 is going to get passed into here. It's going to get passed into the iteration exponent, into the next iteration exponent, into the, okay, and then that omega naught becomes a 3. Okay, well, let's write that out, and I'm going to choose to write that out now with kind of more ordinary arithmetic on the omega naughts. Okay, that's kind of big. So this is, again, this should look familiar. This is in an iteration exponent, inside an iteration exponent, we get yet more exponential behavior inside there. And of course, remember, the part of the key is that all this stuff, the W naughts are immensely powerful, and especially the W of W naught lurking in there has a lot of unevaluated omega naught power. Okay, let's just expand this out just a little bit though. So this is omega naught times 2 to the omega naught times yada, 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 yada. What is the highest degree iterated exponent? It's this last 2 to the omega naught. The 3 gets fed into the omega naught, becomes a 2 to the 3, and we get omega naught times 8 here. Okay, so I'm not going to do the explicit kind of expansion on this that I did before, but you can remember or go back to, a couple videos ago where when you do start eating this away with a 3, you're just going to feed 3 into it repeatedly, repeatedly, repeatedly until you get to a successor. And it's not too hard to see that's going to be some super complicated expanded alpha plus 3. Okay, so this is not the same alpha we had before, but it's going to have the same general flavor. It's going to be the super big expression with omega naughts and iterated exponentials plus slightly less iterated exponentials plus slightly less iterated exponentials plus like omega naught plus 3. And so this alpha you want to think of as a pretty darn intricate gadget on its own. Okay, so now what's going to happen? It's going to look a lot like that explicit example I did a couple of videos ago. We're going to do this erosion expansion of alpha plus 3, and every time we get to successors, it's going to say, okay, do more E's on this W naught, which is already got this lot of hidden power in it, okay? All of that is happening. That's just to describe this guy. That's all happening in the iteration exponent of that other E. And so that's going to create this unbelievably complex gadget with the buried omega naughts that are sitting inside these W naughts. Okay. Whew, we're getting somewhere. So that's all I'm going to say about that one. I'll save the really gnarly expansions maybe when we get into a new level. Remember, at the phi1 level, we haven't gotten that far. So this is analogous to when we discovered f of omega and then went to f of omega plus 1. That's just doing the barest. That was doing the barest level of arithmetic on omega, or sorry, omega naught here. And now we're doing that in the phi1 inside the control exponent of an outer phi naught, but it's not that. There's still clearly a lot more we can do in the phi1 level. But I think it does pay to take small steps, mainly because if you're doing this stuff and whenever you try to skip steps, you recognize, oh, I tried to skip a few steps and then it refers back to the steps I skipped. So let's see, what's the next one? We'll just do a little bit of expansion on the next one. What happens if I actually take omega naught plus 2? And I'll go back to the 2 level on the outer exponent, just not to be too crazy. Okay, so that's the phi1 of omega naught plus 1 function, iterated omega naught times, but really that's just iterated 2 times because I'm feeding the 2 in. That iteration is pretty simple to write. Okay, and now what have we got here? Let's see. So the phi1 of omega naught plus 1 is an iteration of the phi1 of omega level, which I was calling W. So remember, that W is code for one of the most powerful functions we've seen. And now I'm iterating that guy this immense, quote, number of times. It's really a function. And then I need to unpack that guy. Let me scroll down a little bit. Okay, so how does this guy unpack? Okay, that's again a successor. So this is again the phi1 of omega naught something function. That's W. It's iterated omega naught times on omega naught. Okay, finally I've got something I can actually feed the 2 into again. So the 2 feeds into this this whole thing. It feeds into the iteration. It feeds into the iteration exponent on that, and it's just a 2. Okay, let's see. We have an abbreviation for W of omega naught. That's this bold W naught gadget. And I'm putting that into a W, and then I'm Wi'ing that. So I hope the abbreviations don't make it seem too tame. Let's just contrast, right? What were we doing here? We got something that looks formally kind of similar. We've got E to the stuff with W naughts, and then it's all applied to a W of W naught, right? And what do we got here? It's the same thing, but with W's. We've got a W to the W, and everything is at the W level. Remember, W is an abbreviation for the diagonalized version of the phi1. It's something that will use not just phi1 of 2 dot and 3 dot, but all of those guys with incredibly big numbers plugged in as soon as the expansion really gets going. Okay, so let's look at that. So here's where we were, right about here. So, oh yeah, here we got to about here. So W of W naught. Okay, so a W of something. Let's see. I need to fix something. Okay, just wanted to double check something. So remember, W of something, I want to unpack that just as the definition. So that's phi1 of omega naught, comma, W naught. At this point, it's not impressive. It's not really using its full power because that's just going to hit the 2. The 2 is going to go in the iteration exponent, and it's going to go straight into here. So it's just phi1 of 2 something, which we're considering is not incredibly impressive. But the other w's are things that are going to get much, much bigger inputs into them. So that's just w0 times 2 to the w0. Okay, not so impressive maybe. Okay, now I'm going to unpack that. So w0, again, when we put a 2 into it, is just going to be phi1 of 2 omega naught. Okay, so now as I was saying before, we're getting some fairly mundane arithmetic at the omega naught level. We're getting repeated exponents with omega naught. It's not even repeated that many times. That 2 to the omega naught becomes a 4. Omega naught times 4 becomes omega naught 3 times plus 2. We've seen this before. Omega naught, then that plus 2, you just rules of exponents. That's a times 4. But notice that's in the exponent of the w there. Okay. And then that's going to start expanding just a little bit more. Okay. Now, this is again going to be one of those expansions that's going to get bigger and bigger and bigger, and eventually is going to hit a successor. And then that's finally going to start telling the w, hey, do some more w's, do some more w's. But you're going to have a lot of untapped power still in that iteration exponent. So how would we describe that verbally? So the number of repetitions of w, which is this very flexible diagonalized version of the phi1, it's controlled by an intricate expansion in w0 itself. And those guys are going to lurk and are receptacles for really, really bigger and bigger numbers being plugged into their first slots. And of course, it's all applied to this guy, which has a lot of omega naught in powerful slots. Okay. So in particular, this exponent here that's in the input here, you're doing just incredibly fancy constructions that are building all kinds of stuff on this, while the omega naught right here stays unevaluated until very, very late in the game, and it's going to explode in a tremendous way. Okay, that's a good place to be here. On the next video, I think we're going to be ready to at least tentatively do the big diagonalization that happens at this stage.